When you get into trying to solve these problems around static equilibrium, there are several things you need to do. One is, first, ask the question, is it in static equilibrium? Because it may not be, but most of the time I'm going to pose that as part of the problem, so you're good. Draw a diagram. Drawing a picture really helps. Got to remember, this is physics. It's about physical systems, so the closer you can relate it to something actually happening in your mind, the better, and drawing a diagram helps with that a lot. And then you're going to start with the two basic conditions. The sum of all the forces equals 0. The sum of all the torques equals 0. And what you're going to do, and you'll see this when you get into me solving some problems, is you're going to pick your pivot point to make your life easier. You're always out to make your life easier. Because here's my basic statement. If an object is not spinning, right? If it's not spinning about every single point on the object. So you get to pick which point to do all the calculations around in terms of which point is it not spinning about. If it is spinning and it's in rotational equilibrium, then you have a clear point where it's spinning around as your pivot point. But if it's not spinning, if it's sitting still, then you get to pick, right? Now let's look at this problem and think about that. On this problem you've got, you have the weight of this. So you've got this, and you've got its weight. Its weight you put at its center of mass, so in a uniform pole, that's right in the middle. And then you've got this guy that's holding on to it at one end with two hands. One is going to be a force down, the other is going to be a force up. So we'll call this F1 and call this F2, and well, don't really have to worry about the vectors because we're all in one dimension up and down. Well, I could put the pivot point here. I could, but I know the weight. Let's say I know the weight, because if I don't know the weight, I don't have to know two of these. But all right, I know the weight. I know what the mass of this thing is, so I know the weight. And so if I put the pivot point here, what does that do to me? Well, I'm still going to have all the up forces, F2, this is one way to do the sums, have to sum up to be equal to all the down forces. So I'm just going to put F2 as F1 plus the weight, or you could do it as F2 minus F1 minus the weight equals 0. Okay, that's one equation. Now we've got our pivot point here, and we've got a distance L2 and a distance L1 for those two distances from our pivot point. Okay, now I have to write another equation. What is going to cause a, this is downward, and so F1 is going to cause a counterclockwise rotation. So F1 is going to cause a counterclockwise rotation, pardon my English. So F1 L1 is a positive torque, and then F2 is going to cause a clockwise rotation, and it's a negative torque. Now, weight. The weight, since you picked that as the pivot point, what's the distance from the pivot point to the weight? 0. So there's not a term for the weight in terms of pivoting, so you've got F1 L1 minus F2 L2 equals 0. So you have two equations and two unknowns. If you remember from algebra, if you have the same number of equations as you do unknowns, then you can solve it. And all you have to do is do some algebraic manipulation to get to where you need to be. Okay, that's one way to think about this. I'm going to give you another way to think about it that makes life a little easier. Instead of looking at F1 and F2 causing a pivot around here, since it's not pivoting, as I said before, it's not pivoting about every point. So I'm going to call F1 my pivot point. Now what do I have? Well, F2 is going to cause, all right, a positive rotation about that point. And so F2 onto, all right, it's going to be L1 minus L2, but we know what those are. So that's my positive torque. And what's my negative torque? Well, negative torque is going to be caused by the weight, so minus the weight times L1 equals 0. Now, what's the advantage of putting the pivot point right there versus right there? Well, let's look at this equation. F2 onto L1 minus L2 minus WL1 equals 0. How many unknowns are in that equation? 1. And because it only has one unknown, we already know F2 right away. You know, the other thing you could do, if I ask for F2, then you want to go to there and you've got the answer, voila. If I ask for F1, then put the pivot point here. Why? Now the torque equation, right? Now the torque equation is going to be, let's see, positive torque is going to be by F1. Positive torque is F1. So F1, and this is going to be, again, L1 minus L2 is the difference. And negative torque is going to be from the weight, and that's going to be minus WL2 equals 0. And voila! So you have F1. You have F1 for free, almost, right? And so you get to pick the pivot point and do that carefully so that it makes the rest of your life easier. And that's it for this little talk.